Hi grade 12s. Okay, as promised, the area sine cos rule video. Let's quickly start with, okay, so here's a diagram that I've drawn for you people. This is triangle ABC. We label, if this is capital letter A for angle A, the side opposite it can be represented with a small letter a. Same for angle B, the side opposite it can be represented with a small letter b. And same thing for what angle C, opposite it would be small letter c. So if you see me using small letters, then know that I'm talking about the sides. And if you see me using capital letters, know that I'm talking about the angles. Okay, I'm going to start with the area rule. Now, up until grade 11, wait, you guys were taught this in grade 11, so up until grade 10, you all knew that the area of a triangle is half base times perpendicular height. But what happens when you're not given the perpendicular height? You can use the area rule. So like for example, this triangle over here, if I didn't give you the perpendicular height, but I gave you the side here and the side here and this included angle over here, you'd be able to calculate the area of this triangle. So if you look at it, it's basically the two sides and the included angle. Two sides included angle, two sides included angle. A nice quick way to remember this is if you look at the alphabet A, there's a side, and an included angle in between the two parts that make up the A. That's just a quick way for you to remember it. Okay, anyway, let's talk about the sine rule. The sine rule is, I've written it down over there when to use it, but basically it's when we're given sides and angles and we need to be solving for other unknown sides or angles, right? I've written it as sine of the angle over A, sine of the angle over A, sine of the angle, sine of the angle over B, sine of the angle over C. Does it mean that this is equal to this is equal to this? No, not at all. This is very similar to when we were talking about proportion. Did it mean that the sides were all equal to each other? Absolutely not. It just meant that they were in ratio. Okay, so the ratio, if I calculate the ratio of this one, it will equal to the ratio of this one. It will equal to the ratio of this one. Since we're talking about ratios, you can totally flip it the other way around, making it A over sine A, B over sine B, C over sine C. Another thing, you do not have to use all three. You only have to use two of them. And you generally use where one of them has information, whichever one, and one has information either at the top and information missing at the bottom or vice versa. Okay, we are going to talk about it a little more when I tell you when you can use which rule. Then we talk about the cos rule. Okay, in the cos rule over here, still same triangle that we're working in, right? If I'm looking for a particular side, it's equal to the other two sides added minus 2 times the other two sides. Oh wait, these were sides squared added minus 2 times those two sides times cos of angle A. Again, you would notice that the angles here are all included, okay? Another thing, please don't forget, I've written it on this page as well, please don't forget that since we're working with a squared, once you calculate this on your calculator, please don't forget to square root both sides. It's a very common error. Most people forget to do that. Right. With the sine rule, we also have something called the ambiguous case, which is exactly what I've written here for you. If two sides of a triangle are given and an interior angle are given, right? So I'm going to scribble over here on my page. Let's say here's my triangle. I've given you this side here and this side here, and I've given you information about this angle. If this side over here, let's say I gave you this is 15 and this is 10, right? If this one over here happens to be smaller than this one over here, then two triangles actually exist. Okay, that's what you need to know about this. Now, in terms of it, you don't ever have to write that this is the ambiguous case or anything of that sort. You're just going to see if you're given two sides and an angle, and the side opposite the angle is the shorter of the two, then you should know it's ambiguous case. And you should know that when we're calculating this third angle over here, so angle here, this one over here, or potentially this angle over here, basically, yeah, then what you should know is that where was I? That this angle over here has two possible answers. It's an ambiguous case. We don't know which one of them are true, right? So what you need to be able to do is just know that if you're calculating this one here in the possible big triangle, so to say, then it's going to be calculated as normal. And if you calculate in the other possibility of that angle, you're just going to say 180 degrees minus whatever this answer was. I've given you an example over here and you can go through it on your own. Let's just raise this up. Sorry, shadows that can be seen of me. There we go. Right, you can try it on your own. What's the important part is, if you see ambiguous case, how do you identify it? You should know how to identify it. Once you've identified it, know that there's two possibilities. That's the first one. The second one, 180 degrees minus. Okay. Right, I've also spoken about angle of elevation and angle of depression over here. Angle of elevation is exactly what it is, looking all the way up. I said that if this was the ground and the person is standing over here and that was a light bulb, the angle of elevation would be if this person was looking up, or from their foot, from them all the way to the top of the light bulb. The opposite is also true for angle of depression. It's when you're standing here at the top and you're looking at an object at the bottom. Now, what's important to remember about angle of depression, here I filled it in for you. Don't forget, we're going to be working like in a triangle. So like, for example, here's our particular triangle. And if we're working in the triangle, this angle is actually equal to this angle. How do we know that? And you see a Z. If I drew a line over here to get that angle of depression, it's perpendicular to the baseline that we're using here at the bottom, or the ground, or the water, or whatever it is at the bottom, therefore making this angle equal to this angle. Don't forget that. Don't forget that it is alternate angles. Okay, I've also done a little diagram for you on bearing. I'm sure everyone knows this: north, east, south, and west. You are going to see questions where they include the bearing, so please know about which direction is which. All right, important things to remember: do not round off before the final answer. Like, for example, if you calculated a particular side and you need to use that particular side to calculate another angle or whatever it is, please use the answer button on your calculator, or you can store things on your calculator. So I'm going to pause for a second on trig and just show you guys how to store things. Let's say we had I don't know, let's go with sine 50 over, no, let's type in sine 50 over 3, for example, right? Gives us this, and we want to save this. What you would do is shift, there's a button here for store, okay, and then you're going to store it anywhere you want to. If you look at your calculator, there's alphabet A, B, C, D, E, F. There's a whole lot of them. I'm going to just save it or store it at A, so I'm just going to press the button that has A above it. There we go. You should get this. It means it's stored at A. Okay, let's say I had to do another calculation. I don't know, let's go with sine 25 over 3 times 8, I don't know, whatever, and we have to get the angle size, so shift sine, sorry, my thing actually didn't work out. Let's try that again. Sine 25 whatever, let's say that's our number, okay, and we want to store it to another alphabet. Shift, store that button over there, alphabet B. Now let's say I needed to add these two particular things. I know I'm deviating a bit from my trigonometry. I'm just showing you how to use a calculator. Let's say I needed to add those two numbers. How are we going to find it on your calculator? Or how are you going to be writing it all out in your book? No, what we can do is you press alpha A. Remember, alpha A was that first number we stored. Did I store them both at A? Okay, let's start this again. I'm sorry, guys. Sine 25 over 3. Let's go. Shift. Store A. Right. Sine 25 over 3 times 8. Whatever. Shift. Store B. There we go. Let's do this. If I wanted to add them, then you would press alpha A plus alpha B. There we go. Now I've added them and I haven't compromised the accuracy of my actual value, because it's all on the calculator with all the decimals that it could possibly be. Sorry for making so many mistakes in between. Anyway, let's get back to what we were talking about. I also wrote that it's important to put units. Sometimes we're going to tell you that we're working in kilometers or centimeters or meters or whatever it is. Please put your units. And I wrote your square root when applicable. Remember I mentioned, let's go back here, right? If we had this value, if you calculated the whole thing, you put in a value here, put in a value here, put in values over here, you get your answer. Don't forget that this value is squared. So you're going to square root on one side, and what you do on one side in an equation, you do on the other side. So that's what I mean by square root both sides. All right, now it brings me to when do we use which of the rules. Area rule, obviously when you only calculate in area, and in this particular case it's when you are given or when you are asked to calculate area but you are not given the perpendicular height, then you use the area rule. Okay, when do you use the sine rule? When no right angle is given, obviously, because if a right angle was given, then you'd be using your ratios: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You'd be using those. But if no right angle is given, but two sides and an angle is given, or one side and two angles, so opposites of each other, two sides and an angle or two angles and a side, right? I also wrote here not the included angle, so the one way it's the included angle, you're going to be using basically the cos rule. So two sides and an included angle is given, or else if three sides are given, then you can also use the cos rule to determine one of the angles or two of the angles. Okay. Another important thing to remember is to note that we are working in triangles. So since we're working in triangles, don't forget that the sum of interior angles of a triangle add up to 180 degrees, right? That's very important. Okay, so the way I've structured our questions that we're going to be going through, I'm actually going to stop this video after I explain how I set the questions up, so that if you need to, you can just find the questions that you want to go through. I've got the basics, okay, so normal sine rule and cos rule, walking through them. Something a little more complex like this, where you have to be determining the length of the side here given information in two different triangles, right? Or something like this, where they tell you something, this is the ship, this is another ship, and this is a lighthouse. Determine the length between the lighthouse and ship, stuff like that, right? Here's another question that I was talking about. I did mention this in class as well. I told you guys that you're going to get bearing questions, where, for example, we'll say the aeroplane is traveling from Johannesburg to Cape Town and it moved slightly a certain amount of degrees out of the way. How much more does it have to turn the whole aeroplane around to reach to its particular destination and stuff like that? Okay, so these type of questions. This question over here, by the way, all of these questions I got from the Siavula website. I'm just making a video using those questions to explain to you, okay? This particular question, I used it in 2019 with the grade 11's test, and the majority of them didn't understand at all what was happening, right? So we're going to go through this one. It's a bit of a complex one, right? And lastly, as per the request of some students in class, exam level questions. I found this from a past paper. It says in the diagram below, but I just realized I forgot to draw the diagram. I'm going to do that in the separate video that I have for you guys on each of these different types of questions.